Hi everybody, my name is Justin Jarrell. I'm the Chief Commercial Officer at Takeo Bio. I'm here today at the SITC Spring Scientific Conference in San Diego, California, and what I'm going to be presenting today is our recent work where we performed unsupervised clustering analysis to identify novel immune cell types that are associated with response in melanoma patients treated with anti-PD-1 therapy. And this work we've actually done is in collaboration with Dr. Boland at Mass General Hospital. So how did we do this? Well, first we had to start off with profiling some samples. And we profiled actually 145 PBMC samples from 85 patients with stage 4 melanoma that were treated with anti-PD-1 in the first line setting. So we took those 145 PBMC samples and we stained them with the 40+ marker mass cytometry panel that we developed at Takeo in order to generate the data set, which represented about 29 million immune cells characterized. So we took those 29 million cells and we did two things. We performed unsupervised clustering using a program called fast phenograft. And what that does is it'll take all those cells and then it will cluster based off of the similarities in the expression of the different markers on them. So when we first did that, we got about 48 clusters. Then, in parallel, we also did manual gating on these data in order to identify and quantify cell populations and functional marker subset. So we did that, got about 36 of those. And then what we did at that point is we took each of those clusters and we looked to see, by using a cosine similarity score, how similar they are to any of those gated populations. And those that were the most similar, we reassigned the cluster names to them. So all of those 48 clusters now had a cluster name to it. So that was the first part of our analysis. The second part of our analysis was to see, by manually looking at each of these clusters, is it actually defining them properly based off of the manually gated cell population? And for a majority of them, they actually did. They worked out great. But there were a couple of clusters. And for example, cluster 16, which is represented over here, that actually looked a little bit off from what we saw in our manual gating and what the cosine similarity score matched up with. And this cluster 16, when we looked at what was closely related to it, it was actually looking like a CD4 positive central memory T cell. But in reality, when we took a closer look at it, it actually looked a bit different. It did show a decrease in CD45 RA expression. But when it came to CD27, which in high expression is a defining marker for that subpopulation, it was variable. What you can see within this cluster is that some portions were highly expressed, low expressed, and mid-tier expressed. So it's sort of all over the place. Then, if it's not a central memory T cell, what actually is it? What is, if we look at the entire map and look at all the other marker expression, what actually is defining this cluster? And what we see here is a higher expression within this big portion here is CD161, and a lower expression of CD39. So when we apply that to this cluster 16, the new naming to this is CD161 positive, CD39 negative, CD4 positive T cell subset, which is a brand new one. So cool, interesting. We used unsupervised clustering to identify a new cell type that was missed in manual gating. But does it have any biological relevance to it? It's like, great, you found it, what could that mean? So what we did then is we took that cluster, or we took that cell type now, and we looked to see, okay, if we compare the responders and non-responders based off of the frequency of that population, or on the expression levels of these different markers within there, is there anything statistically significantly different between them? Frequencies, they worked, but when it came to markers, we did see some differences, particularly with T-bet expression and CCR7 expression. With T-bet, we saw an increased expression level in the responders versus the non-responders within the CD161 positive, CD39 negative, CD4 positive T cells. And conversely, we saw the opposite effect with CCR7, a decrease in the responders in comparison to the non-responders. So what does that mean? Well, there actually still is a lot of work to be done by our team and team at NGH to figure out what does this all mean in terms of the relevance to melanoma anti-PD-1 response. There has been some literature that has suggested that the prevalence of this is correlated with good prognosis in certain cancer types and certain therapies. However, again, a little bit more work needs to be done in order to fully flesh out what that all means. But generally speaking, what we're trying to demonstrate is there's a really big place for unsupervised clustering when it comes to high-dimensional cytometry analysis. Manual gating, great way to go. A lot of a priori knowledge in order to understand what's going on. But when you add unsupervised clustering to that in parallel, what you may find, and what this has revealed, are novel cell types that you would have missed by just doing manual gating. So with that, I want to thank you for taking the time to let me bring you through this presentation. Again, my name is Justin Gerald. My email, if you have any questions, is justin@taco.bio. If you need any more information on what we do at TACO, we make high-dimensional cytometry simple for clinical trials. You can visit us at taco.bio on our website or reach out to any of us to answer any of your questions. Thank you.